Okay, we can get this kicked off here. This is our Industry Luminaries panel, and we have a really great set of panelists here that are industry experts across IT companies and IT users. Our panelists have variety of backgrounds and experiences that we're going to dive into a little bit today. And this is an open cloud workshop, so in true cloud fashion, we actually hot swapped one of our panelists and did a replacement, and no one even noticed. Clouds work. It's great. Panelists as a service, I guess you could call it. It's a new PaaS. But I wanted to kind of organize this around some themes and have a lot of things to talk about over the course of the panel. Three main areas that I wanted to kind of get into are around the kinds of technology collaborations and technology transfers that happen when you bring together the different groups that we have represented here at the Open Cloud Workshop among industry organizations and academic and research organizations. Also, I wanted to dive into open source specifically. That's very much personal interest of mine, and talking about the way that open source is really driving innovation and has been for the last few years, and then also talk about some of the challenges that we face in the open source world, both in kind of creating communities and consuming the software as users, because I also think that's another big purpose that we have by bringing this larger community together around all of the open cloud projects and also the kind of open cloud instantiations in the form of the MOC and the NERC and the open cloud testbed. So that's kind of where I want to take it today too. But I also this is a perfectly sized room to kind of have a discussion. So we have mics up here, and if any of you have questions or want to contribute a thought or grill one of our distinguished luminaries, feel free to come up at any point. We won't just hold it for the end. And to get started, I wanted to go ahead and ask everyone to introduce themselves. So maybe we can just start down on that end with Mark and then work our way back.
Hi, everybody. My name is Mark Astley. I manage the data engineering team at 2 Sigma. 2 Sigma is, I guess we call ourselves a diversified financial manager these days. And we've been involved with the MOC since day one, I think. We do a lot of open source, both as a consumer and a contributor back. And I guess that's it for now.
Hi, everybody. I'm Dave Cohen. I work at Intel. I've been working on distributed systems for longer than 30 years. My focus now is on persistent memory in the context of distributed systems.
Good afternoon. My name is Stefanie Chiras. I run the Red Hat Enterprise Linux business at Red Hat. So clearly, Chris gave you a great view of what we do for a living at Red Hat. I think the interesting thing about having in this community with RHEL in particular is RHEL is kind of the foundation of clearly the install base that we have with Red Hat. 90% of Red Hat customers have RHEL, and they're looking to how to take that Linux experience from what they have done into what they want to do in a hybrid cloud. And so it serves as that base transition platform. It underpins our OpenStack. It underpins our Kubernetes environment and OpenShift. So understanding how all of those play together is critical in the roadmap that we drive for RHEL.
I'm Gene Bagwell from Verizon. I'm the lead architect for the Verizon Cloud Platform. We're working on converting all of our existing PNF infrastructure over to VNF on OpenStack and Kubernetes environments. I run a deployment that's roughly covers 60,000 sites across the continental US and 220 sites internationally.
Hey there. I'm Brianna Frank. I'm Director of Product for IBM Cloud, and we really focus on looking at our client use cases and designing products that based on open technologies that are solving specific challenges. And so far, what's been interesting to me is that many of our client challenges are very similar to what we're seeing in the university sphere, whether it's billing or security or even compliance in some cases. So very interesting.
Great, thank you. And I'm Jonathan Bryce, Executive Director at the OpenStack Foundation. I have been a solo developer and a IT integrator and a data center operator, and now I'm at a nonprofit, so I guess I've never been good enough at any of them to last that long. Ron thought that I should moderate this panel, and he'd give me a shot at a fifth career now. To start, I wanted to actually ask Gene and Mark to give us just a little bit more color about those environments that you're talking about. As users who are consuming technology, open source and proprietary technology, what is, you mentioned 60,000 sites, Gene. Obviously, this is to power a network, but can you give us just a little bit more insight into what it's like to be Gene and to have that kind of an operational profile? Who are your users, your customers? How do the applications get deployed? Just a little bit more color around that.
Sure. A year ago, I was operating basically the wireless infrastructure for Verizon Wireless on PNF infrastructure from Nokia, Ericsson, Samsung, buying extremely expensive customer or vendor-provided hardware. We decided that as we started to roll out 5G, we wanted to follow a cloud-native approach, and that basically threw our entire infrastructure into a tailspin. Instead of buying hardware that was custom built to go into environmentally unfriendly environments, basically sitting at the bottom of a cell tower, we now had to take commodity hardware and to figure out how to adapt it to fit in environments that could be anywhere from minus 20 degrees to 120 degrees. How to secure it at the edge, so security at rest. How to deploy and manage 60,000 instances of what we call vRAN to virtualize the network infrastructure just for wireless. And then you compound that with Verizon's international offerings, our VMG group, which most of you guys know as Oath and AOL, and you've got a huge effort. I was doing some math earlier today at the back of the room, and roughly right now we have depending on how you count it, between 3.6 and 4.8 million cores performing workloads today. So that's pretty much where we're at right now.
Oh, that's it?
Yeah.
3.6 to 4.8.
Yeah, 3.6 to 4 million.
Yeah. I think what's interesting is really what you highlighted about the shift has not just been from kind of proprietary to open source, but also that has resulted in something that is purpose-built, highly integrated, to something that is now this sort of layers and layers of different technologies that you are piecing together to get to the end solution.
I mean, we used to buy all of our hardware from our vendors. Now we're being the integrator. We're undertaking the effort. I saw the presentation about FPGAs. Every one of my edge nodes has an FPGA in it now. And we're looking at newer technologies. Instead of putting FPGAs in the computes, we're looking at putting FPGAs in the fabric and running user plane workloads in the fabric itself using P4 programmable ASICs. It's a complete change. When we rolled out 4G, really 10 years ago, it took 4 years of planning. We're doing 5G in 18 months.
That's awesome to see the kind of the shift, but I'm sure, like you said, it's daunting and
It is daunting. Keeps me up at night.
Yeah. So, Mark, could you give us a little bit of the background on your environment and the kinds of workloads and challenges that you're facing too?
Yep, sure. So Two Sigma is not a very old company. It's almost 20 years old. And so from the start, it was run more like a startup. And so that creates a lot of scarcity in terms of resources. And so we used open source, frankly, because it was a cheap way to go. So we've always been a Linux shop, and we started with Java, and because it was you could get the JDK for free and things like that. And so since those days where the data center was also our office, we've now gone up to a site with 3 data centers and maybe 3 megawatts or so of power and lots of servers and lots of colos and so on. And the use of open source has grown, but also shifted a little bit. It went away from just purely something that enabled our growth, but also a way to tap into a lot of data science, especially that's going on. So a couple years ago when Python really took off and things like pandas and so on, those are the things that we wanted to use because the people we were hiring already came in pre-trained to use those things. And so we started attaching onto those communities for that reason. And so today, our use of open source, it's still very strong in sort of the infrastructure of things. And if you come work for us or talk to us, you're going to see Kubernetes, a little bit of OpenStack, although it's pretty hidden these days. A lot of other open source infrastructure things, but you see a lot more emphasis on things that are upstream. So you're going to see Python, Pandas, Spark, all those sort of tools as well. And that's been the bigger growth area. And also the places where we have contributed back to the community have been in those places, not so much in the infrastructure these days, more in sort of the top end tools. That's been where we've seen the most growth, at least in open source in our community.
Okay, thanks for that. So kind of just open to the panel overall. This is the industry Luminaries panel, which congratulations, you're all Luminaries. This is good news. So have any of you had a background in the academic space or the research space prior to your work in industry? Yes, Stefanie, could you talk a little bit about what your experiences, how they compare, and where you think some of the things that, as we look to form some of these collaborations, that we should be thinking about to maximize the opportunity to kind of take the research and the science and the experimentation that happens in the academic space and make sure that translates into the things that are practical and applicable in the industry and the real world kind of customer space.
So one of the things that struck me this morning when we spoke, and it actually comes in a lot of different ways, is the difference in timeline, right? Certainly when I was in research, the timelines are a bit longer than they are when you're going quarter to quarter in a business or in an industry. And I look at a similar aspect when it comes to the hardware changes versus software changes, right? Hardware take you 3 years to design and deliver a chip, right? Used to be 5. Maybe if you're lucky, you can get it in 3, but it's a long time. And now we're developing software in order to go onto that hardware, and that software has to be much faster. When I look at this whole aspect of what we're doing between hardware and software co-development, between cloud access versus on-premise access and traditional hardware access, it comes down to how do we merge and come together on how you bridge with good communication across different timelines. And when I look at the projects where industry and academia and research need to come together, it's about looking at short-term value gain along a progression of long-term problems to be solved that are going to change the industry and really make a difference in the industry, but communicate in a way where you can bridge those timelines. I see so many aspects in what we talked about this morning that's all about timeline, and we used to have the luxury to operate in different timelines. We don't have that luxury anymore. Right? With FPGAs, with GPUs, with tool sets being created, with new applications being developed, we have to work together to shorten those time spans. And that to me, as we look at how industry works with research, it's about how do we really sit down and articulate the problems where we have a long-term goal, we have short-term value. One of the things that stuck with me, and sometimes it's not obvious. When I look at what we need to understand better about cloud. And it's just one example, but all of these aspects about heterogeneous hardware and giving access to developers, for example, in heterogeneous hardware and building tool sets. We also need to understand just how people want to consume in a public cloud. Whether you're a researcher, whether you're a developer, how do you want to consume? So for an industry perspective, understanding that, and you probably see it at IBM Cloud too, understanding those aspects of just how they want to consume, the ease of use, the ease of access. How do you learn that in the short term while you're trying to solve the longer term problem of just running a really efficient, operationally heterogeneous cloud? So to me, it's about really articulating short-term goals against a long-term problem.
So if I were in an academic institution and I wanted to successfully partner with you, what would be an example of some of the short-term progress that would be motivating to Red Hat or Intel or IBM? You know, any of you can jump in, but what are some of those the examples because I think that's an excellent point, but to kind of bridge the differences between those timelines. Brianna, go for it.
So, you know, I feel so, it's almost a luxury to have an amazing IBM research team that can help support us in the product, because they are looking, you know, they're looking ahead, and it's a luxury to be able to have that kind of resource that is you know, prototyping and solving problems and figuring out what can and can't be accomplished. And so that allows us to move faster. But, you know, not just in the IBM research division, but we also have design research. And I think that's actually an interesting aspect as well, where we have our designers looking at how users are consuming our technologies and kind of figuring out, like, what are the pain points? Where are they, you know, excelling, or where are they having some struggles? And that allows us to kind of fine tune what we're delivering in a way that's more and more consumable. So I think both of those aspects really help us. You know, again, we're talking about accelerating. I think the reality is today you have to deliver at such a fast pace, and so you need to have some of these levers to consume. So whether it's IBM research or your user research, you know, both have to work together to allow you to really accelerate your delivery.
Anything to add, David?
Yeah, so the operational aspect, I think, is one of the most interesting, in that, for example, when I worked at Goldman Sachs, I'll never forget Mark Freeman, who was on the trading side, telling me why he didn't want to see me anymore. It wasn't because he didn't like me, but when he's talking to an IT guy to get more storage capacity or to have a network connection turned up, it's a bad day. I'm just in his way. And he's like, you know, Dave, the cloud gives me a portal. I just go in and it gives me the experience of infinite capacity, always available, and I never have to talk to somebody like you. And
he wants you back in the basement. It sounds
in
like.
the basement, in the data center. But what it really means is we're just inertia for him to get his stuff done. And so getting stuff done and how you actually build operations that is silent, that's never in the way, that's like the real challenge for what the end user expects. Mm-hmm. And the cloud has set that expectation.
Yeah.
Until something breaks, and then they want the direct line to your desk, and they want to know why you didn't pick up on the first ring. Having dealt with traders now for 13 or 14 years, that's how they roll. So.
Yeah. Yep. Are there any?
I think that's the goal, is that, you know, how do you consume cloud in a way that you never have to talk to a human? I mean, I think that's like they're very well articulated, and that's definitely something that we're trying to make sure occurs. And you have to test, and that changes over time, because you're pushing new code into production, you know, hundreds of times a day. So that's opportunities for, you know, things to happen or things to break. And so it's really important that you're constantly making sure that users have that great experience.
I have a question. Is this on?
Just give it a minute.
Okay. About that apparently infinite capacity, we've had a lot of trouble with the billing for that infinite capacity, because we think we have infinite capacity, And at the middle of the year, we get a bill which appears infinite. And we have no money for the rest of the year. And that's a disaster. And I'm wondering, how do you prevent that sort of issue?
You don't. To be honest, you don't. I run into the same problem in the commercial world. You know, we forecast for, you know, $250 million for hardware infrastructure capacity, and it's gone by the end of the first quarter, and you still have 3 more quarters worth of deliverables. It's a struggle on both sides, both academia and commercial. So I don't have an answer for you. I just know that it exists on both sides.
Just one thing I would add to that, right? I think as you look at all of the decisions that get made with the deployments, whether it be on the infrastructure level or the application level, it's largely about how do you balance between capability and the experience that you have with it or the ease of use. And that kind of teeter-tottering, right, continues to rise up, and that's the role of all of us, is to figure out how to make it easier to use and increase the capability. And I think that's part of what was alluded to this morning, too, about this whole repatriation, right, of people who went to the public cloud and now want to go back. It was so darn easy to deploy that suddenly the bills got astronomical because it wasn't well tooled, it wasn't transparent, and I think now we're starting to get to the point where the knowledge base of understanding what capabilities do you really need and where do you need ease of access and make those decisions in a way that really makes sense. And that's going to take some learning, and it's going to take tooling. And how do we come in with tooling and capabilities so that you know where to put what when, and have transparency across that billing? There's a long way to go before that is really, really clean and easy. But I talk to customers all the time who have the same problem you have. It was so easy, and it's so darn easy that their developers in the back room are logging up to the public clouds, and they have no idea. They have no idea. So to me, as we look at how we improve this whole cloud experience, it's about how do we continue to build up capability, continue to focus on ease of experience, and those two things increase without trading off one for the other too much, and have transparency across. It's tough. We are heavily focusing right now on the, I say procurement, but it's not really procurement officer, it's the buyer. What is the experience of the buyer in a hybrid cloud? And that's like a whole new set of tooling and capabilities that have to be developed in this area.
Yeah, one pretty large OpenStack user had a private cloud. They started using public cloud, and they ended up going back to private cloud. And they said that when they went to public cloud, his analogy was, he said that it was like sending his developers into that shopping game show with the carts, where you just run around and you like throw as much as you can in as fast as you can. And then, you know, he was getting these bills for incredible amounts of storage and GPU usage and all these things that, you know, hey, it's in the cloud. And I think you're right. You know, this is the technical capabilities to some extent have exceeded sometimes our organizational capabilities to, you know, to handle them responsibly and sometimes. But James, you had a question.
Could I go back to the academic and industry collaborating in open source? Because it got mentioned by you. You talked a bit about your journey from becoming just a user of open source to becoming a contributor. One of the things I tend to see in academia is that this becoming a contributor doesn't often happen. I mean, those of us who have to review academic papers have a lot of them where the student does all this work and it's never got upstream, it's never published, never done anything. So given that we have at least 2 of you on the panel who've done both academia and industry, how do we embed open source into the DNA of academia in the same way that we seem to have managed to embed it in industry, primarily in industry because of necessity, right? If you don't actually become a contributor, you can't use it efficiently. But the same doesn't seem to apply to academia. So can you give me some thoughts as to how we could assist this transformation? I mean, academia gets it partly. That's what the Open Cloud Workshop is about. But it's not embedded in the training we give to students or the sort of encouragement to get stuff upstream and actually make a contribution in open source.
So there's a dirty trick, which is make your own GitHub project, and boom, you've just contributed, right? But from our perspective, so it's hard. As much as we love open source, not all communities are equally open to taking contributions, and that's just a reality of the way things work right now. So when we contribute, we spend a lot of time getting involved in the right community. Sometimes we invest in some of these communities as well. So it's not strictly, here's our code change, please take it. We also get to know these people at conferences and places like that. We ask if we can sponsor some of their projects, and in academia, that's not always possible. I guess one thing that's kind of interesting, I was thinking about when you asked about academic participation. So before I was at 2 Sigma, I was at IBM Research, and I've seen some of my former colleagues here. Back then, we used to talk to standards committees all the time, right? Which, is some sort of torture, I think. But anyway, and now we don't do that anymore. We talk to Apache, or we talk to people that are running certain things. I haven't talked to a standards committee in years, I think. So the people who are sort of the guardians for these things have changed over time. And so now, in our current role, we find ourselves talking much more directly to the people that are running a particular project, or the right Apache organization, or sometimes vendors that are helping to shepherd changes. That's the other path we've taken as well. You can do that with OpenStack, for example. You can do that with some of the other big open source things out there as well. Will that work for academia? I don't know, but that's what we've had to do to make it work for us.
For students, when it comes to students, I have a high school freshman, and so I always try to encourage him and his friends, and they actually are signing up for AP Comp Sci next year, so I'm super excited. But what I try to do is give them a little bit of industry, real reality. And I remind them, gosh, 20 years ago when I graduated from college, I printed out my resume on this really nice cardstock, and I handed it to, and I had a face-to-face interview. And today, if you're working in the open source community, Kubernetes in particular, you don't have to do that. Basically, you can just tweet that you would really like a new opportunity, and there'll be 100 job offers in that tweet. And I keep seeing that over and over again, and I try to show people that that's not an anomaly that happens all the time, and that's how valuable those skills are. And so, at IBM, we have, 68,000 developers that are, approved to contribute in the open. And most people do that for their own career progression because it's such a valuable, there's not enough skill in the world in these technologies. So if you can prove that you are contributing and that your code is actually pretty good, you're going to get hired. So I think that's the most compelling reason, and you kind of have to infuse a little reality into some of the students and get them, pumped up about contributing.
Jonathan, could I respond to that as well? Or go
Yes.
ahead, Greg. No.
So as far as, contributing and getting code back into the upstream community, I wish Verizon was big enough to push code into the upstream community. Unfortunately, we have to rely on our vendors like Red Hat and IBM to help us get changes into the upstream community. Mainly because although we do contribute a lot to both Kubernetes and to the OpenStack, we don't contribute enough that we have a large enough voice in the community. And that's just, that's the way things are shaking out. I'm working on a project right now where I need to get a change into CPU manager for Kubernetes, and I'm having to go back through Red Hat to get that change adopted, or help get that change adopted.
That echoes a little bit what I was going to say. At Red Hat Research, the one really hard criteria we have for whether or not we fund a project is whether there is a Red Hatter who's willing to engage with the student, with the PhD who's working on the project. And there's two reasons for that. The first reason is that it sort of automatically vets whether that project is interesting to our engineering. But the more important reason is that graduate students don't have time to get their patches into upstream projects. If they did, they would never actually complete their degree because there's just too much to do, right? If a graduate student is working with a Red Hat engineer or an engineer who is already engaged in an upstream community, the chances of that research being relevant is greater, and the chance that the research will in some form actually make it upstream is also much greater. So I feel like that's kind of a solution to that problem, but it takes a lot of engineers. So there you have it.
Aram.
So you guys have been talking about academia as kind of one sort of target for engagement. And I really think that in this community, at least, I see there being three different communities. There's the people that are using clouds here and real usage of a cloud environment. There's the people that are actually IT folks who are actually standing up these cloud environments. And then there's the people like me who actually do systems research and change Ceph or change OpenStack or change Kubernetes and stuff. I think you've been primarily talking about people like me, but I think that what excites me about this whole open cloud is actually that there's bringing that 4 or 5 or 6 communities together, sort of the 3 communities I see in academia of I can do relevant research because there's real users and we're actually standing up a production service at scale. And I think that, you know, from industry, there's the people deploy, the people users. Can you talk about those other communities here? Did that make sense?
So you're talking about the...
You've talked about the challenges of adapting research changes into upstream software and into the technology, but there's actually the value of participating in kind of initiative with IT leads that are standing up a production service. Mm-hmm. You know, the value of actually engaging with open source cloud where, you know, the telemetry might be available. I mean, you know, the question is, does Giovanni have access to the telemetry from IBM's cloud, even inside IBM? Oh, okay. That's interesting. What's that? But in general, that's not the case for most researchers, right? Mm-hmm. So I'm kind of curious, is that engagement with those other sides of this community valuable?
So are there opportunities to take some of the kind of capacity for research and specifically like research around the operations and sort of like the smoke trails that these software projects put off as you operate them, right, and to provide that to researchers who can look at that and identify patterns or opportunities for improvement, or is that kind of what?
Or even just the sake of, you know, there is a visible, you know, with NERC we'll have a relatively large scale cloud could be used by hundreds of thousands of students, you know, is actually a cloud where the telemetry from that is available to the open source community, for example.
Yeah.
So innovation can happen with access to it, or that experimental services could be deployed in a cloud, you know, from say Intel. Is there interesting technologies you'd want to expose, you know, as a demonstration before going into the public clouds, for example, right?
Yeah, I think I know what you're saying. So so one of our AI groups is actually looking to build an AI product using some of our cloud logs. But we can't share the cloud logs because those are locked down and they're secure and they're compliant. But if there was a cloud that was completely open and we could study some of the logging and it wasn't locked down and it was open, I think that would be very interesting. So I think is that kind of what you're getting at?
Yeah, except he just said he had access to that. Maybe he built that in before he gave it to you?
Yeah, that's probably what happened.
Yeah.
The challenge is that if you're part of a regulated industry, you're using data, if that cloud is running data from customer workloads, you have to follow not just your best practices, but also regulation of that industry you're operating into. So creating an environment in which that data may be easier to share, which is outside what is a regulated industry, that would be valuable for everybody. Even I'm in IBM research, and I'll be able to access would be great for us too, of course.
That's the kind of question I was asking about. What could this environment produce that's valuable to you guys?
I think the other thing, Oran, just to build on that, the thing that I find most exciting about this whole project that we heard about this morning is that there's people who build hardware for clouds, there's people who build the clouds and how they work and the tooling itself, there's people who build applications by using the cloud, and then there's researchers who consume kind of the capabilities that the cloud provides. And those are very, very different aspects, and all of them, right, we could use benefit from how they do what they do. And I think what's the opportunity that's in front of us is how do we articulate where each one of those, what they want to do, where it needs to go, and sort of get all of those streams running in the same direction. And I mean, we struggle with that in the industrial sector for sure, and I see it in customers all the time. I mean, their developers and their app dev people don't talk to their infrastructure team. How do we use this as a microcosm to start to bridge those gaps? It's a tough problem, but I think that's the biggest opportunity that this community that you has in front of them, is how do we bridge that? Because even for the people who are building the cloud, if during the building of that cloud you can get short-term feedback from the users of the researchers to go back and say, listen, that tooling doesn't really work for me, or that feedback in that loop provides kind of that 360-degree view. That's what this community can deliver, which I think is the most exciting opportunity. If we can't bridge those multiple viewpoints in this kind of a microcosm, it's really hard in the industry, right? And it's really hard once you get into an individual customer like Verizon, because they all have their own dynamics. It's just a tough.
So,
So Ron, just to contrast I'm thinking like Mike and Kai and the guys at Princeton, and the way that they cycle their students through Facebook as one illustration. Like, they've published tons of data that's pretty amazing. So what's just to contrast, like, that model versus what you're talking about? It's not as clear.
I think that there's definitely lots of things that we've been successful in academia in doing by having our students go off on internships at Facebook, Google, Microsoft, and then have them collect certain data inside there, and us writing papers with them. But I don't think that that's the same as allowing us to do sort of experimental things, right, ourselves as researchers, or deploy kind of certain things to our customers. Right. So there's some aspects that, and we actually had the talk with Google's cloud folks. They were sort of saying, well, why don't you just use Google's cloud? And I was saying, well, that's great. Can I just have access to all the telemetry about all the usage of it? And they're like, nah.
yeah, I think that's one of the pieces that gets back to like Hugh's presentation about ops first, and the part of what we're trying to do is something that is it's sort of live, constantly changing, because of all the aspects that you were talking about, where the hardware is changing, the software is changing, and the usage is changing, and those factors come together in very unexpected ways sometimes. I started the Rackspace Cloud, and we grew it from a handful of servers to over 100,000 at the time that I kind of left that group, and this was in 2005, and at the time we were constantly surprised by the things that would break that you would think are pretty solid, things within just the Linux networking stack or things like this, and I think that's kind of what you're getting at is at some level it's not just about taking a snapshot from a partnership with an organization or a static analysis of a piece of software, but it's this trail that gets left behind as you try to operate these things. Which maybe brings up a question that would be interesting to get the panel's perspective on. What is your view, and individually, your views on the future of cloud computing? Do you think that it's going to be a hyperscale-only world? Do you think that there will be real private clouds? Do you think that there will be edge clouds? Like you mentioned edge nodes with FPGAs. Like what do each of you see as the real future for cloud computing over the next decade?
I mean, definitely a move away from, at least for Verizon, a move away from the VNF world to the CNF world, but then taking microservices to the next level. Right now, every one of our applications comes with its own set of microservices. How many different microservices do I have to authenticate a token from a user's phone? Shouldn't I be able to create one service and have all the other different applications authenticate against that token or that service? I'm curious how we're going to continue to innovate, you know, with the more services that we have to provide you, the subscribers. It's getting harder and harder to keep up with the demand. You know, we just recently announced that we were able to do 800 gigabits per second across a single light wave. 2 years ago, the limit was 200 gigabits per second. At the rate we're going right now, next month I'll need to do a terabit, especially with 5G rolling out. So I don't see how we're going to be able to continue the rate of change given the physical limitations of the hardware that we have today. Something's going to have to, some of you guys in academia are going to have to figure out how to break some more of those laws of physics and give us greater, bigger, faster hardware. But as far as virtualization goes, I mean, we're 110% committed to virtualization. It gives us so many benefits, not only the cost benefits, but you know, the ability to reuse hardware. You know, 2 years ago, if I had a project that failed, I had to start evacuating hardware out of my data centers. Now I just repurpose it to the next project. That's a huge gain for us. That's a huge innovation for us. It's basically a game changer. I don't know how you guys feel about it.
So yeah, cloud overall, any thoughts?
So I personally think that computation and the importance of computing on data is just skyrocketing. There's no limit to what's going to happen with that. And the implication of that is that computation has to be completely globally available all the time. If you don't have computation, then you're kind of the odd person out. And I think that is the future. There's no turning back.
I kind of think of it as, I always think of it in the perspective of the user. And I feel like, you know, if you look around probably this campus, everybody's face is buried into their phone, and they're probably bumping into each other because they're all, you know, so concerned about what's on their phone. And I think there's so many patterns that people are still having to manually type into their phones instead of our, you know, applications guessing, you know, what the next step is going to be, or using facial analytics or whatever it is to guess what our next step is, and to kind of take out some of those steps that would allow us to look up more and interact with humans and not be so buried into our phones. And to me, that's kind of where the future is. But to your point, to get there, it's going to take so much predictive analytics and so much computation to allow that to happen. That's kind of where I see the future going.
I think when I look at how public cloud has sort of taught the world about a new way to experience things, going forward, to me, it's about creating maximum flexibility and increasing the efficiency at the same time. When you look at the flexibility you can do today, public cloud, you can have services, you can have IaaS, you can have on-prem, you can have containerization, you can have microservices. I mean, the choices are all out there, but the efficiency isn't really there to be able to pick and choose what you want when you want it and turn and pull it back or move it here and there. The real goal, I think, is when we're going to have maximum flexibility with the choice of the hardware, and whether or not it's all hyperscalers or some boutique types of cloud access, right, or services where it's just so damn good at one thing, but efficiently you can use and pick and choose with essentially, you know, level playing field. That to me is the beauty of where this could go.
So I can state with a fair amount of confidence that we're not going to be 100% public cloud for the foreseeable future. Part of that is just the nature of the finance business. A certain part of the business has to be right up against the market. And so we're always looking at a hybrid world. There's a couple other things. I guess I'll be Debbie Downer for a little bit. So security has really lagged in the public clouds, and in our particular business, we want to use the same services that everybody else likes to use in the public clouds or not public clouds, but without a way to create real VPNs in the clouds and real protected resources. That's difficult for us to do, so that's limited some of the growth we can do. The other thing is there's pricing, which we haven't really talked about yet. We have to pay money for the clouds. You would suppose that eventually the clouds won't need to overbuild so much, and so the spot level pricing and the reserved pricing can sort of meet closer somewhere. But right now they're pretty far apart, so that affects our usage. And I guess the other thing that's sort of interesting to us is we don't use hybrid clouds just because we have to mix two environments. We also use it as a way to deal with other counterparties and other people that we have to work with. So we don't want to. We need to work with outsiders sometimes. It's not feasible to let them into our environment, but it is feasible to meet them in other clouds. And so that's a use case I think might grow more in the future. We've certainly enjoyed that capability.
Yeah, we're starting to do the same thing using hybrid cloud environments to collaborate with our vendors.
So I want to circle back to something that you said a minute ago, but first, you've been waiting so patiently. I want to give you a chance to speak.
Thanks. I'm Steve Heller, and my pronouns are he and him. One thing which was talked about was repeatable research, and that's something I've been looking forward to for a long time. And it occurs to me that our industry luminaries represent industry where repeatability and consistency has probably been more important than in academia, and they may have some key learnings to advise that as the academics try to get repeatable research, what are the key things to go for first?
So thinking about repeatability, I think that a lot of times that comes to scale, like you talked about, Gene, or customer scale, like Intel, Red Hat, IBM have.
The first thing about scale is Verizon scale breaks everything.
So at some point, there's nothing that's infinitely repeatable.
There's nothing that's infinitely repeatable. Every time we think we've solved the scalability problem, it just creeps up and bites us in the backside again. Our biggest challenge was going to a declarative model for how we deploy our applications. I mean, in years previously, it wasn't such a well-defined model, but now that we've taken on orchestration and automation tools and become our own integrator and basically eating our own dog food, making everything so that when you're deploying, whether it's the infrastructure or the application, you have a well-defined process, you have well-defined and documented environment variables that define this application being deployed in this site. And once you understand how it works the first time and debug it, then I can say I want to deploy, and I'm going to use an industry term, a PGW here in Boston, and be able to use the same templates with site-specific information to deploy one in Dallas, Texas. It took us a long time to get there. Deploying gateway functions, which are how you go from the radio network to the IP network in the wireless industry, that used to take months to deploy those. I mean, physical infrastructure was part of that, but also just configuration. Now that we've gone to a virtual environment, I can spin up a new PGW like we did for the Super Bowl overnight and have it work and know that it's going to pass all the testing that the FCC is going to do against us, ensure that it's going to be able to deliver 911 calls to the local PSAP. You know, it's once you get there, it's I don't want to say nirvana, but it's a great way to run your business. It also comes with its own set of issues because you take all the people that used to know how every little detail of their particular little silo worked, and now you've automated it. And now you've got to have somebody that not only understands the automation, but also understands how to go back and figure out, oh, well, we hit a code point and a SIP message that no longer works correctly because of a code upgrade. Well, when did that code upgrade get deployed? How did it get deployed? Why did we not miss it in regression testing? So it's a great way to work, but it does have its own issues too. And I don't think I really answered your question, but.
Well, it sounds like some of what you're saying, again, is like that ops first, where you have to consciously decide to take on the overhead of designing the operational automation first, rather than just trying to deliver an end result, because you know the ultimate end result is something that requires that operational excellence.
So
And I was going to echo, you know, at IBM Cloud, we do the same thing. You said, you know, eat your own dog food. I like to say drink your own champagne, but we run all of our IBM Cloud services on Kubernetes. So before we deploy to a client, we've actually tested that with our entire internal, you know, cloud. And, you know, that makes a big difference, especially because, you know, some of our large clients say, you know, everything works great until, you know, they roll it out into their huge, you know, system, and that's when things break. So we've already sort of built that scalability in, and you know, you're talking about automation, and I think that is a very interesting cultural aspect. And so one of the things I notice about our team is that if we get the same question twice, a GitHub issue is open. So either the documentation or the product itself changes. And I think that's a really important sort of cultural, you know, way of life that you kind of have to infuse into the team, because then your product is constantly getting better. If someone's asking a question, then chances are they're running into a problem. And that's a really important iteration or cultural method that I think has really helped in terms of, you know, testing things internally before you push it out. And it's nice too when you're using kind of a friendly audience. I wouldn't say they're always friendly. Usually your colleagues are the hardest ones on you, but that actually, you know, infuses a lot of quality into the product.
That kind of depends what standard you have to hold yourself to. As soon as you decide to use algorithms to guide trading, that's pretty serious. And so, you know, changes to math libraries can be really bad. So, you know, if you want to hold yourself to that level of discipline, it's much easier these days than it was in the past. Now that there's a lot of infrastructure as code and ways to codify their dependencies, it's gotten much easier for us. In the bad old days, you know, it was somebody writing down all of the library versions that we were using, and then invariably when you had some strange result, you had to go back and manually go through and figure out what changed. These days, though, it's much easier with the tooling to get this right the first time.
The infrastructure as code approach is probably one of the biggest benefits I see, because now we have AI engines that are checking configurations of gateways and things like that, making sure that even the automation didn't screw something up. Sorry.
Thank you.
Thanks. Dims.
Julia, she had a question she had to.
Okay, you were the designated line holder.
Yep.
So it wasn't really a question. It was more a comment regarding researchers and people contributing back to communities. And I feel like we're not, as a culture, we're not doing a good job of communicating and recording. We're thinking that cloning a repository in GitHub and pushing our change into it and not making that visible somehow contributes to the community at large, and it's not the case. And the same thing, like raising up what the telemetry data is, or if the community doesn't know it's there, they're not going to find it. And even then, they're probably not going to have a business priority to cause them to go find it anyway, unless there's a business need for it to occur. So at some point, there has to be an interchange of those thoughts, ideas, and information, and I think that's what this is to me.
Yeah.
Thank you.
So just increasing the visibility is actually a positive step at some level, because there already is a lot of things happening out there that maybe people don't know about inside of the communities or inside of the academics. Did you have?
I'll keep it quick. If there are students here who are interested in open source, as part of Kubernetes and CNCF, we are running Google Summer of Code and outreachy programs. So please tell them to apply for it. That was one thing. The other one was I'm part of the Kubernetes steering committee, so I am always in the lookout for trying to figure out where people have issues in terms of contributing to the project itself. So so Gene, as well as anybody else in the audience, if they have trouble with coming up with or working through the contributions to Kubernetes or other CNCF projects, please hit me up so we can try to smoothen the experience a little bit. Thank you.
Yeah. So let's talk a little bit about open source and innovation. A lot of times, open source has kind of had this label on it of it's kind of like a fast follower, or it's copying proprietary technology. But I think that we've really seen that shift to some extent in the last 5 to 10 years, where we actually see a lot of innovation happening first in open source. And I think that the cloud and cloud native spaces are great examples of that, where containers, container orchestration, machine learning, a lot of the state of the art has actually happened more in the open than first versus more in a proprietary world, and then kind of being copied by open source projects. My question is, along with that, as I said this morning, that's great, but it's also it's problematic in the sense of the pace of change that we've talked about, just the amount of information that if you want to stay informed and kind of able to evaluate these decisions of what do you run, what do you not run, it's very hard now. So my question is, across your organizations, how do you look at open source? How do you look at the projects that come along, the things that are on the horizon, to evaluate them, to decide what to use, what to productize, what to get involved in, and how can we think about that as operators and open source communities to sort of like send better signals and make sure that people can make informed decisions around that?
So I'll start with kind of the one basic example of how that fits in. Certainly with our world on Linux is in what you spoke about earlier this morning, Jonathan, was all of the different projects get out of sync with one another because they're all starting to drive innovation at the rate and pace that is expected of them within the community set. And that varies whether or not you're something like a Linux kernel, which is pretty stable and you got a whole lot of people depending with their businesses on it, to something like Kubernetes, which is clearly an industry leader with what it does today. It's kind of like the chosen path for container orchestration, but heavily dependent to have innovation come in rapidly to sort of that newer stuff, right? That's like just figuring out who's gonna take the lead dog slot, right? As we've looked at, and I'll use Linux and Kubernetes as an example, Kubernetes clearly has huge dependencies upon the Linux kernel with which it interacts once you go into a production level deployment. Your security depends upon it, your stability depends upon it, your resiliency depends upon it, et cetera. So as we have looked at our portfolio between RHEL and between OpenShift, our earlier versions of OpenShift sat on top of RHEL. And that Kubernetes platform of OpenShift sat directly on top of RHEL, and you had all the fantastic bells and whistles that RHEL has in order to deploy a Linux environment, a Linux operating system environment really built for VMs and bare metal. Kubernetes, however, in the way that upstream community operates is it's iterating much, much faster than the kernel is. And so as we have moved into the latest generation, we've actually changed how we build, deploy our RHEL kernel and our RHEL code in order to be optimized for that level of consumption, right? So we took our RHEL, we honed it on down, right, into about 400 packages, right, from about 3,000 into 400, the ones that were needed in order to support a Kubernetes environment, and we deployed it as a core OS like immutable core. And that was particularly because your Linux world and your communities was operating at a much different pace than your Kubernetes world. And when you wanted to deploy in production, you had to find out how those two worlds work together. That's one example, and we still have a lot of learning, I think, to do as we move forward in that space. Now, as you move into the rest of the tool chain in particular, that's churning at a much faster pace. Where do we find these heavy technology dependencies between the two communities? How do we figure out how to work those two? I mean, for us in Red Hat, our goal is to make the portfolio work together. It's all open source. You can still do as you wish in the free world of open source, but it's not for the faint of heart, right, to build and pull all of that together. And that's kind of what we have done to try and do as a business. But it's not just about what it does, but about how those interact. And it's not easy. I mean, we can certainly tell you it's not easy. So the next layer, I think, is how do we take something like the community that we have here and identify those key dependencies that either are critical for security, are critical for operational excellence, are critical for efficiency, are critical for dependencies for application development or new hardware capabilities. How do we flesh those out and start to figure out how we pull it together, at least so there is a thread that works? The struggle here is you can't over-constrain it, otherwise you inhibit the innovation. So, we at Red Hat have taken a view of how we focus our portfolio to deliver that sort of production level view. I think the public clouds have a whole different way of being able to deploy that because it's kind of all behind the curtain, right? And there's a lot of flexibility behind the curtain on how you make that work. But in this type of agreement between where we look at academia and upstream communities and how we bridge that back to the industry, I think working together to figure out where that golden thread has to really meander through, that's a really important, early look ahead that this kind of community could help provide.
Mm-hmm. Mark, do you want to care about any of this, or would you rather it be hidden behind a RHEL license
this is like
or
an
a public
IQ
cloud?
test. What's the right? So I guess as a consumer of a lot of open source, there's kind of two buckets. There's the open source projects that are backed by the Red Hats and Googles of the world, where we know somebody's going to pay attention to those things, and there's low risk. And then there's everything else, and there's a lot of awesome in the everything else. And so in that world, relationships matter more than anything. If students out there, if you're doing an open source project and you put it on GitHub, and we send you an email asking you about it, it really behooves you to respond to us, because that's how we're going to build a relationship and take you seriously. So that's kind of how we decide. When we go to places like this and we meet you and you tell us about your awesome projects, we're going to follow up on some of them and try and build a relationship. And that's how we build trust. And it doesn't always mean that we're going to use your stuff or invest in your idea or whatever, but that's how we have to sort of figure out how we're going to use certain things. That, if you can manage to get one of my colleagues here to take your stuff, that's awesome too. That helps a lot. But that's what we see a lot of. And so frankly, that's why we invest in communities like this, why we sponsor things like PyData and so on. It's so that we can start building these relationships. And we're not the only ones. There's a lot of our peers in finance and elsewhere. That's why we're investing in this community, is so that we can pick out the good things as well.
So you kind of have this two-tier approach of they're the mainstream projects, and you mostly let kind of the industry take those, but you actually see a lot of value coming out of the long tail of more unknown open source projects.
Yeah, because the bigger players have things they're trying to accomplish as well, and they're not 100% aligned with what we're trying to do. And they also have limited resources. They can't consume all the awesome stuff that's out there. And so for certain needs that we have, we go and we look at GitHub and all the other places as well and see what we can find. And what is really good for us is when we find something good, and we also see that somebody's trying to advance this idea through Apache or something like that. There's another place for us to attach and help support the community.
Do you have any examples of like some specific projects that just as kind of more detail?
Two big ones that are quite big now. Well, one is more nascent. So Pandas, for example, we hired Wes a couple of years ago. That was the way we invested in that one. We saw Pandas is a super important library in Python for doing data science. 5-10 years ago, it wasn't that popular. It started growing in popularity. We had an opportunity to fund Wes quite directly by employing him. And so we did it. And we started investing more in that community. And from that, he started working on, he and some other colleagues worked on something called Arrow, which is now starting to grow in popularity. And we're investing in that as well. So we've done that a few times. There's other cases where we have invested indirectly by having companies help us get interesting changes to us upstream in various ways. But in sort of direct investment, we've done it a couple times.
Mm-hmm. Okay. Brianna.
I think innovation comes from collaboration, and sometimes that means that you have to make some changes or take a different path than you originally planned. And so a couple of examples I can think of in the microservice mesh space. A lot of times what IBM will do is we'll open source a piece of technology just to show what our perspective is in that and how we're solving that particular problem. So a few years ago, we open sourced a project called Amalgamate, which was solving a lot of some of the trafficking issues within microservices. And what happened is other people noticed it, and Google and some of the engineers from Lyft. And so we came together because we were solving essentially different parts of the same problem. And so we came together and we formed Istio. And so I think there's lots of examples where you might start off solving a particular problem, or maybe you open source a specific project, but then it sort of morphs and changes. And I think you have to have collaboration and the flexibility to work with others to say, all right, here's where this is going to evolve to. And maybe that eventually moves into Kubernetes itself. I don't know. But I think that's part of putting your perspective out there and not being afraid to open source your version of how you're solving the problem, but then allowing that to morph and change and evolve over time and not kind of trying to control it, I guess, is the let the project go where it may.
We've done similar things where we've invested in technologies, that although not interesting to us at the moment, we see potential in them 3 to 5 years down the road, to the point where we've recently formed a group within Verizon called Verizon Ventures that actually goes out and looks not only for startups that have interesting technology, but individuals that have interesting ideas that need funding in order to see them through.
Yeah, one thing that I think is sometimes lost in the world of kind of like, it's almost like big open source, like big pharma or big agriculture or something. We have these very large projects like Linux and OpenStack and Kubernetes that I think are there are barriers to just driving change in them that in most cases are actually by design within the communities, because the communities are so big that if there were no barriers, then it would be chaos. But at the same time, there are still many projects out there where a single developer or a half-time developer can really drive a lot of value and deliver something that's really useful. And I think that this is a great point that both of you brought up, that I want to make sure that we don't lose sight of that part of open source in the world of kind of the big projects that are more of the blockbusters that we see now. Were you going to say something, David?
Yeah, I was just going to say, I mean, it's interesting to listen. Yeah, the stack has obviously like Kubernetes at the top, just as an example, and the Linux distribution, kernel, et cetera. But one of the weakest points in the stack is really the BMC and the firmware. And so like a community like this, it would be an awesome place to dig in, because the most uncertain part of the environment is almost always the BMC and the firmware. It's the most risky place. It's the easiest to screw a lot of things up, and it changes very frequently.
Mm-hmm. Yeah. Are there any questions in the audience? James, again, you are like a question machine. You are a panelist dream audience member.
So I had a question specifically to Brianna's point, which is, you mentioned Amalgamate and Istio, where the code was released early. Everybody saw that there were a couple of other groups working on it, and you all agreed to collaborate together. It doesn't always happen in open source. Sometimes these 3 projects develop independently, and we get competition between them, which we have to resolve, or sometimes never resolve. Things like GNOME and KDE, they're still 2 separate desktops on Linux. They're almost never going to come together. Can you speak a bit more about the benefits of collaboration in open source versus the benefits of competition? Because I think we regard both as valuable, but it's useful to determine when one is more valuable than the other.
That's a great question. Yeah, and I don't know that I can pretend to, I don't know that I can pretend to tell you when one is better than the other, but I think that healthy competition is really useful. And I think if you have people that are really thriving in the open community, it's because they're not afraid of that competition, and they, kind of embrace it a little bit, and that's healthy, right? But then when sometimes, and I'm sure we've all seen that in the community, where you've got whether it's egos or folks that are really in particular very attached to a specific project, and they can't evolve with the project, and then that starts to make the whole community suffers, right? So you got to have that healthy competition, but then you also have to kind of bring the projects forward together, or the community I think suffers, and that's the hard thing. It's like, when do 2 projects need to converge, right, for the greater good? Because if you're really solving the same problems, maybe it's time to converge. And I think that's where the tension. You need to be like a peace. You need to have some sort of negotiation skills, or I don't know, hostage negotiation skills to make that happen.
It's super interesting, the KDE GNOME versus Kafka and all the other streaming platforms. I do a lot of work in the streaming area right now, and it amazes me that there's at least 10 viable alternatives to Kafka. And I don't think any one of them will stand alone in that context, but I totally see the reason that it would be ideal to have a single desktop and kind of converge on that, especially in the maturity of both of them. So it's a really interesting kind of space or contrast. The streaming area is really kind of nascent. I don't think it's solved. The edge and IoT and a lot of other stuff is driving a lot of innovation in that space. So I think the answer is somewhere in that contrast.
And there's plenty of copying that happens too. So usually, whoever comes out on top, if somebody does, they've copied plenty of features from the most recent front runner. We saw this play out when Kubernetes was starting to come out, and there were other solutions. So Mesosphere was out there as well, trying to offer the same solution. And we saw features being copied back and forth. You could run one on top of the other for a while, and some features merge. So that's not necessarily a happy ending for everybody, but usually the end user gets most of the features that they want anyway. So at least from our perspective, it usually ends up okay.
Yeah, I think my perspective on that would be that some of it depends on the maturity, like David said, and also the addressable market. If it's a bigger market, then there's more space for more options. If it's a smaller market, then if it's fragmented too much, then sometimes all the projects starve and never really kind of get critical mass and get enough resources to get to like a truly viable piece of software that people can trust and run on. But I think that the reality, going back to something that we've talked about a few times, a lot of times these projects do operate in kind of an isolation mode and don't necessarily evaluate the landscape like a commercial company would to think about a product line, and sometimes that's why you end up with these. And then of course with something like KDE and GNOME, there are all kinds of cultural issues that have, what do you run? What do I run? Do I like you because you run KDE? But Oran.
So there's a question I wanted to ask Chris, but we ran out of time there. So I was curious what your perspective on it is that we've seen this sort of enormous agility in the hyperscalers, by having these CI, CDs, and being able to continuously evolve software really fast, right? And of course, in the open source community, we generally, get a patch and then it gets put into a release 6 months later, and you might find out that, hey, there's this performance anomaly due to that patch. Do you see cultural barriers? Is this even, if we could develop that kind of CD, is that a plausible thing for the open source community, or is it sort of culturally incompatible? Or what are the barriers? Do you think that kind of approach could evolve for open source?
I think it's about, at least for me, from a product perspective, the first thing we do, and of course all the developers in the room roll their eyes, but the first thing we do when we're building a new product is we have a design thinking workshop, and everyone hates it. They do not want to use Post-it notes. They think it's a complete waste of time. But what happens is you bring all your stakeholders in the room, and you're forced to create hills, quantifiable hills, the who, what, wow. And once we go through the exercises, everybody's bought in, because when you're done, you have very clear objectives, measurable objectives, and you never have to talk about them again. You can just go 1,000,000 miles a minute and actually go into your MVP and deliver your alpha or beta or whatever. That's working extremely well for us at IBM. We are moving extraordinarily fast. It is a very different and cultural change. There's all kinds of things that have to happen with that, whether it's transparency of bringing out problems. So for example, as a leader, you can't yell at the team every time you see a problem, because all of them have to be surfaced. And that can be scary, right? So there's a lot of cultural changes. This, like I mentioned earlier, culture of automation. Whenever you get the same question twice, you have to think, well, clearly there's a problem here I need to address, whether it's within the documentation or with the product itself. Even answering questions. So instead of answering a question with the actual answer, what we do is we always answer with the documentation, because that makes sure that the documentation is update and is actually working and you can follow it. So a lot of cultural things have to happen. And so, but what it really comes down to is prioritization. And that is so hard, right? And it's hard within a big company, because everybody has different, everybody has different outcomes that they're looking for. But if you can get agreement on the prioritization, then executing is not the problem. It's the prioritization, at least in my experience.
Prioritization is a huge issue. We run into the same problems, where we go through a very similar process, and I absolutely love Post-it notes because they're all over my office.
I need to work with you more then.
But once you get the priorities, then everything else really seems to fall into lockstep. I mean, that's one of the ways we've been able to innovate and deploy our 5G network as fast as we have. We didn't have that 10 years ago. We didn't have that approach 10 years ago when we were rolling out LTE, 4G. And it was like organized chaos trying to figure out, has this site already been upgraded? When is that site going to upgrade? How soon can we get circuits in place, to support turning up that market? This rollout, and I've been through 2G, 3G, and now 4G, and now 5G. This has been the easiest one, and it's got the most benefit or potential benefit to the subscribers. I'm really looking forward to when we get it up and running nationwide.
To piggyback off of that a little bit, I think a CI/CD environment for open source can help to be a tip of the spear, right? I mean, the problem is that in any CI/CD environment, some options have been selected on your behalf, right? And that's what open source. The beauty of open source is that you can choose anything, right? So you want to preserve that flexibility so that all of those new things coming down the pipeline and those individuals who are making incredible contributions, they don't get squashed out. So I think it could work well as a tip of the spear to accelerate innovation on some level of pre-selected choices that have been made to create that CI/CD environment. But it has to be positioned in a way that that's what it is. It's not the end-all be-all. It's not going to be the magic panacea for all of open source, because you don't want to get rid of all of those individuals who are doing great, unique things. But I do think there's a place for it.
You want to see some people really go at it, hook and tail. Get two different guys that have different ideas about how things should be stored and get in a room and let them figure it out.
What we see in good open source projects is, so good CI, CD, and unit test coverage allows pace, and you always want to see an open source project that's been updated fairly recently and it's only through stability and testing that you can actually get away with that and not have the whole thing blow up. So that's a positive indicator for us on what are good open source projects to follow, and internally as well, it allows faster changes. I think you also asked, I think, about can you teach this or how do you teach it? I'm not sure if that's really what you were asking. All I can really say is it's a little glib, but they don't necessarily teach these skills in undergraduates as far as I can tell. So, if you want to impress us in an interview, write a unit test and talk about CI/CD. You will blow us away because we don't see the class of students coming out, at least from undergrad, having these skills right now. Maybe that's changing. But to the students out there, if you really want to blow us away, already come trained knowing how to write unit tests and at least one CI/CD pipeline. That'll be great.
All right, Chris, I think we have time for one more question or comment. So you are, take us home.
Oh, come on, the pressure.
It better be good.
I just, Ron indirectly was asking me a question. Thank you for proxying. Actually, no, I appreciate the input because I think about it in a really simplistic way. One of the things that you were talking about hyperscalers, one of the things the hyperscalers do is that's quite different from open source projects is freeze the functionality, especially from the open source project point of view, and then iterate on specific features and functions and then deliver those. And they actually have pretty sophisticated ways of doing delivery. So your experience is probably locked down for the better part of a year on a certain API where somebody else is maybe iterating. And open source projects have so many collaborators bringing so many different features together at one time that it's difficult to isolate those independent features, which is maybe a little bit what Stefanie was getting at about the configuration choices or changes that you make. I think the way, and so the answer I believe is yes, it's a major change, even cultural change. An example of how that could be, how we could make that change is onboarding broader and broader ecosystem communities into the CI infrastructure. And OpenStack actually tried some of this with distributed CI and third-party CI to get real test feedback from all the unique configurations without fundamentally changing the development model, which is about lots of contributors contributing to a release rather than a developer focused on a feature who's going to then hack, git commit, push to production for some subset of their users. So I think it's a pretty different, whether it's cultural or just sort of procedural, it's a fairly significant change, although I don't think it's impossible. And it starts with real, honest CI.
I was going to add on, you mentioned that OpenStack development process did this with distributed CI systems that could report back to the same code review that everybody was using. And OpenStack also uses a gating code review system. So code does not get merged until it passes a set of tests. And so it's very ingrained into the development culture. What actually became, I think, a weak spot with specifically the distributed CI was the maintenance of those distributed CI systems and those different environments. At points there were dozens of them that were connected into the kind of central code review system, but they were maintained at different levels, so they weren't always providing good signals to the developers. And so I think that's kind of what Chris is pointing out is that I think if you can tie it into existing development workflows, if you can bring in new data, developers in general are happy to have that. But if that data starts being out of sync with reality or blocking the workflow, then it becomes a very disliked part of of the system, and so the maintenance burden on that is something that you have to really take into account. So I think that we are at our time for this panel. I just want to thank each of our panelists. Let's give them a hand. And I also want to thank all of you for participating. I love getting the audience involved too. It's good to know that we're taking it in a direction that's interesting to you. So thank you all very much for coming and also for joining in the discussion.